On today's episode, an aviation first as an AI-powered F-16 dogfights against human pilots. Today's episode is brought to you by Engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on Engineering.com TV today. The remote operation of military aircraft for combat purposes has a surprisingly long history. Gyroscope pioneer Elmer Sperry worked on early pilotless aircraft for the U.S. Navy in 1913. In 1944, the Navy tested an early remote control flying bomb, the Interstate TDR-1, under combat conditions in the South Pacific. And of course, after World War II, guided missiles became the most important area of military research. But to date, all drones have one thing in common. They must either be operated remotely by a human or fly a pre-programmed route. Now, artificial intelligence promises to bridge the gap between the real-time judgment and situational awareness of the human pilot and automatic operation. The Defense Advanced Research Projects Agency's Air Combat Evolution program has demonstrated an AI-enabled X-62A aircraft, a modified F-16, in visual range air combat testing against a human fighter pilot. Artificial intelligence has been developed in several loyal wingman programs to create an autonomous aircraft to accompany and protect human fighter pilots, but this joint DARPA Air Force Test Pilot School program suggests that the technology is ready to replace humans in direct combat roles. The use of the X-62A Vista aircraft as a testbed was a logical choice, since the heavily modified F-16 was originally designed to simulate the flight characteristics of multiple different aircraft. Integrating an AI system into a universal testbed allows engineers to run the AI systems in simulation across multiple airframes, suggesting a goal to create a universal system. The Air Force refers to the system as machine learning and live agent integration, and although no one in the Defense Department is yet predicting the end of the human pilot, for fighter aircraft at least, reduction of the human role in the cockpit has been ongoing for several decades. The relaxed static stability criteria necessary for agility in fighter aircraft requires computer-moderated fly-by-wire systems that allow stable flight in airframes which would be essentially uncontrollable for even an experienced pilot. Fly-by-wire also allows easy airframe integration, since no additional actuators are needed to operate flight controls. But the use of an F-16 variant to test the system opens an interesting possibility. In production for nearly half a century, over 4,600 F-16s have been built, with a typical airframe structural life of 8,000 hours. Many are at the end of their service lives. Conversion of tired fighter aircraft into target drones has been a common practice since the 1940s, including the F-16. But the possibility that an AI-driven automation package could be retrofitted into older airframes could allow air forces to cost-effectively add autonomous combat capability when replacing F-16s with new aircraft. And from a performance perspective, F-16s are stressed for 9G maneuvers with full internal fuel. Removing a human pilot from the system can allow combat operations with sustained G loadings and flight attitudes that would be dangerous or impossible in a crewed aircraft. The ACE program may ultimately be regarded as historic for the first truly AI-enabled fighter jet, but the implications for the multiple air forces worldwide that operate F-16s are clear. If a retrofit program is viable, smaller nations may have enhanced combat capability with the reduction or possible elimination of pilot training costs. The testing continues. Well, that's it for today's episode of This Week in Engineering, brought to you by Engineering.com. For our deeper engineering series, visit Engineering.com TV for exclusive shows like Manufacturing the Future, Designing the Future, and the Engineering Roundtable, not found on our YouTube channel. The links are in the description below. Thanks for watching.